Ladies and gentlemen, welcome, curious night wanderers. Let's drift together into a story written not in books, but in the pull of tides and the dance of shadows. The moon always watching, always guiding. But what if I told you that this quiet neighbor of ours is the very reason life had the time, the stability, and the chance to bloom? Tonight, we will travel across 4.5 billion years, watching the moon sculpt the seas, balance the earth, and keep chaos at bay. Until the moment you opened your eyes for the very first time. Without the moon, you might not be here to hear this. In fact, life as we know it might never have existed. Tonight, we'll unravel a cosmic mystery: how a silent, pale rock in the night sky became the guardian, the clock, and the cradle for life on Earth. And what would happen if it were gone? It is easy to look up at the moon and think of it as something separate, a distant lantern hanging in the velvet sky, quietly marking the passing of nights. But in truth, the moon is not a stranger. It is family. It is a piece of the Earth's own body, torn away in the heat and chaos of a cosmic disaster more than 4.5 billion years ago. To understand the moon is to understand one of the most violent moments in our planet's history, and one of the most important. In the early days of the solar system, there was no calm, no peace. The young Earth was a molten sphere, its surface constantly battered by asteroids, its atmosphere a swirling soup of gases, its oceans not yet born. The planets were still finding their places, moving in unstable orbits, sometimes crossing paths, with wandering protoplanets, worlds in the making, some nearly the size of Mars, others even larger. And somewhere out there was one such world, now known in science as Theia. Theia's orbit was destined to meet Earth's. The two worlds, each young and volatile, spiraled toward each other over millions of years. And then, in a moment so brief, and yet so world-changing, they collided. This was no gentle meeting. Theia slammed into Earth with unimaginable force, a cosmic blow that shattered rock, vaporized oceans that did not yet exist, and melted entire layers of the planet's crust. The energy released was greater than billions of nuclear bombs going off at once. The Earth quaked not for minutes or hours, but for days. Entire continents of molten rock splashed into space like droplets from a boiling pot. From this chaos, the moon was born, not as the perfect sphere we see today, but as a glowing, molten ring of debris circling a wounded Earth. Pieces of Theia, pieces of Earth, dust and vapor, and molten rock, all fused together in orbit, bound by gravity's patient pull. Over time, these fragments clumped together, growing, cooling, becoming a single body. The moon, our moon. And here lies the strange truth. If this impact had not happened, Earth might have been a very different place. Without the moon, the tilt of our planet might have wobbled wildly, tossing climates into chaos before life had a chance to take root. Without the moon, our days might have remained short, a dizzying 6 hours long, leaving less time for temperature stability and the rhythms life would one day depend on. But in those first moments after its birth, the moon was not the pale, distant friend we know. It hung much closer in the sky, a massive glowing presence, filling the heavens. Imagine a moon so large that it covered a quarter of the night sky, its light so bright it could cast sharp shadows even at midnight. Tides in the young oceans, for by now, water had begun to condense on Earth's cooling surface, would have risen hundreds of meters high, sweeping inland and retreating in great, thundering walls. The moon's gravitational grip was fierce, pulling at the seas and slowing the Earth's frantic spin. In those early eons, the moon's surface was alive with change. Volcanoes belched rivers of molten basalt, meteorites scarred its face, and slowly, as the centuries turned to millennia, it cooled. The glowing rock faded into grays and whites. Lava seas hardened into the familiar dark patches we call Maria. The moon settled into its role, a steady companion, orbiting further away with each passing year, but never truly leaving us. Scientists have found evidence of this origin in the moon's very bones. The rocks brought back by Apollo astronauts tell a story in their isotopes, chemical fingerprints that match Earth's mantle almost perfectly. It's as if the moon is Earth's twin, born from the same parent material. This is why most scientists accept the giant impact hypothesis as the most likely explanation for its birth. And yet, in science, certainty is rare. There are still mysteries. Could Theia have been rich in water, seeding Earth with some of the oceans we now know? Could the angle and speed of that colossal impact have been the key to making Earth just right for life? These questions linger, but what we do know is that this cosmic collision was a turning point in the planet's history. It shaped the chemistry of our atmosphere, perhaps stripping away volatile gases and leaving behind the ingredients for a stable climate. It shaped the length of our days, the pull of our tides, and the gentle tilt of our axis. It created not just a moon, but a stabilizing force that would watch over Earth for billions of years. Even now, as we watch the moon rise over calm seas, it is hard to imagine the violence that forged it. We see serenity, a soft, glowing presence, but it was born from destruction. It is the product of a wound that healed into something beautiful. And in this, the moon is a reminder that creation and chaos are often intertwined. Sometimes, the most important things in our universe begin as catastrophe. The moon's birth was also the start of a long and intimate dance. Locked together by gravity, Earth and moon have been partners ever since. The moon pulls on our oceans, and in return, Earth pulls on the moon, gradually slowing its spin and pushing it ever farther away. This dance is slow, so slow that in your lifetime, the moon will drift only about 4 centimeters farther from us. But over the ages, the change is immense. In its youth, the moon orbited at less than half its current distance, and its pull on the tides was far more dramatic. These powerful tides may have been the very thing that stirred life's chemical soup, creating tidal pools that filled and emptied in a steady rhythm, giving molecules a place to assemble into the first living cells. Without the moon's birth, there would be no tides like these. Without those tides, perhaps life would have remained trapped in the depths of the oceans, never making the leap to land. The moon's creation, in this way, was not just a cosmic accident, it was the opening act in the story of life itself. And so, when you look up at the moon on a quiet night, remember that it is not just a satellite. It is a survivor of unimaginable violence, a piece of Earth's own body, a guardian that has shaped the destiny of every creature that has ever lived here. Its story began with fire and ruin, but from that chaos came balance, beauty, and the conditions that would one day allow you to stand beneath it and wonder where it came from. After its fiery birth, the moon began to play a quiet but essential role in shaping the world beneath it. The Earth, still young and restless, was not a perfectly balanced spinning globe. Like a top set spinning on a table, its tilt, the angle between its axis and the plane of its orbit, wavered and shifted. This tilt is what gives us our seasons, as different parts of the planet lean toward or away from the sun over the course of a year. But in the early days, without the moon's firm grip, that tilt might have swung wildly, from gentle angles to extreme ones, throwing the planet's climate into unpredictable chaos. Our Earth tilts at about 23.5 degrees today, a sweet spot that allows for moderate seasonal changes, warm summers, cold winters, and everything in between. But without the moon, computer simulations suggest this angle could have varied anywhere from almost 0 to over 60 degrees. Imagine a world where 1 century, you might have mild weather and lush forests stretching to the poles, and just a few thousand years later, those same regions might be buried under glaciers kilometers thick. Life, just beginning to emerge, would have struggled to adapt to such violent swings in climate. It is here that the moon's steadying hand becomes clear. The moon's gravitational pull locks onto Earth's equatorial bulge, a subtle swelling around our middle caused by our rotation. This gravitational embrace acts like an invisible gyroscope, damping the wobbles and swings in our axial tilt. The result is stability over long timescales, keeping our seasons consistent enough for life to evolve and ecosystems to flourish. To understand the importance of this, we can look at our neighbor, Mars. Mars is much smaller than Earth and lacks a large moon to stabilize it. Over millions of years, Mars's tilt has changed drastically from as little as 10 degrees to as much as 60 degrees. Such changes would radically alter the planet's climate, turning polar ice into equatorial seas, and then freezing them again. Any life that might have begun there would have been constantly challenged by environmental upheaval. On Earth, the moon prevented such extremes, giving life a stable stage upon which to play out its slow, intricate drama. In the earliest ages after the moon's formation, the Earth's wobble or precession was still present, but muted. Compared to what it could have been, the gravitational bond between Earth and Moon was like a slow conversation, where each tug and pull kept the other in line. Over billions of years, this relationship has made our climate remarkably stable, compared to what it might have been, while ice ages and warm periods still occur due to other planetary and solar influences. The extremes are manageable, allowing life to survive and adapt rather than constantly start over. The moon's influence extends beyond just the tilt. It also interacts with other celestial rhythms that affect climate. Our orbit around the sun is not a perfect circle. It shifts slightly over time, and our axis slowly traces a circle in space, like a wobbling top. These cycles, known as Milankovitch cycles, play a role in triggering ice ages and interglacial periods. The moon's presence helps keep these cycles from becoming too severe by moderating the tilt that feeds into them. Without this moderation, Earth might have experienced catastrophic shifts in temperature far more often, potentially disrupting the slow climb from single-celled organisms to complex life. Picture the Earth without the moon, spinning alone in space. Over thousands of years, gravitational tugs from Jupiter and the other planets would nudge its axis into unpredictable paths. The poles might wander drastically, the equator might shift, and the sun's path across the sky would look very different. From one era to the next, plants and animals, if they ever managed to arise, would face continual environmental crises. Many species would vanish before they had the chance to evolve into more complex forms. The story of life might have been one of endless false starts, each wiped away by the next swing in the climate pendulum. With the moon in place, however, Earth's axis stays remarkably stable, varying by only a few degrees over long stretches of time. This allowed ecosystems to develop slowly and steadily, building the diversity of life we see today. The regularity of the seasons became a dependable framework for life's patterns. Migrations, breeding cycles, flowering seasons, and hibernations could all synchronize with the turning of the year. The moon's stabilizing effect is subtle, enough that we don't notice it in our daily lives, but it is woven into the very fabric of our survival. A farmer in ancient Mesopotamia planting barley under the spring sun, a penguin in Antarctica waiting for the brief summer to raise its chicks, a forest in Canada shedding leaves in preparation for winter, all are acting within a stable seasonal framework the moon has helped preserve for billions of years. In its own way, the moon acts as a guardian of time. It has given Earth the kind of slow, predictable rhythm that life can keep pace with. Without this rhythm, the evolutionary clock might have ticked too erratically, with species constantly facing extinction before they had the chance to adapt. The long stability provided by the moon's gravitational lock allowed evolution to build complexity layer upon layer, from the simplest single-celled organisms to forests, reefs, and mammals, and eventually, to us. Even the tilt we have now, that gentle 3.5-degree lean, may have been set in place during the moon's earliest interactions with Earth. When the moon was born from the debris of the Theia impact, it would have been much closer, exerting a far stronger pull on our planet. This early closeness likely helped settle Earth's tilt into its current range, where it has remained with only small variations ever since. That starting stability might have been one of the most important gifts the moon gave us, for it laid the foundation for billions of years of environmental consistency. The moon is often thought of as a passive object, simply orbiting while the real drama happens on Earth. But in truth, it is an active participant in our planet's story, not through sudden interventions, but through constant, quiet influence. The stability it provides is like a background note in a symphony, never drawing attention to itself, but essential for the harmony to exist at all. Without it, the melody of life might have been lost in the noise of endless climate upheaval. From The earliest microbes clinging to rocks in shallow seas, to the flowering of forests and the rise of human civilization, all of it unfolded under the moon's watchful presence. Its invisible hand kept the planet from tipping too far into chaos, holding the axis steady as the sun traced its familiar path across the sky. And because of this, life was not forced to constantly start anew, but instead had the time it needed to grow, adapt, and explore every niche the earth had to offer. Long before there were forests or mountains, before even the first fish swam through the seas, there was water vast, restless, and waiting. The young Earth's oceans were unlike the ones we know today. They were warmer, saltier, and more turbulent, a world of ceaseless motion beneath a sky filled with volcanic smoke and meteor trails. In this early time, the moon hung far closer to our planet, a great glowing disk dominating the heavens. And, though it made no sound, its presence beat a steady, silent rhythm into the oceans below, a rhythm that would become the heartbeat of life itself. This rhythm was the tide. Even now, when the moon is much farther away, it still draws the oceans toward itself, creating high tides and low tides in a predictable cycle. But in those early days, when the moon was perhaps only a fraction of its current distance, the tides were unimaginably powerful. Water surged across the planet's coastlines with enormous force, rising and falling by tens or even hundreds of meters. Great walls of water would have swept inland, scouring the land, then retreated, leaving behind shallow pools that baked under the sun. These tidal pools were not just fleeting puddles. They were laboratories. In their shallow depths, sunlight could penetrate easily, warming the water and concentrating the chemicals dissolved in it. Here, molecules could meet, collide, and bind together in ways that were far less likely in the open ocean. Each tide's retreat would leave behind a rich stew of minerals and organic compounds, and each return would bring fresh waves to stir the mix again. This constant cycle of concentration, drying, and mixing may have been the very process that allowed simple chemistry to cross the threshold into biology. Life, in its earliest form, needed both stability and change. Stability so that fragile, new molecules could survive long enough to replicate, and change so that new combinations could form, testing different pathways until one worked. The moon provided exactly that balance. Its tidal pull was regular, repeating without fail, allowing early life's chemical experiments to run again and again for millions of years. Without tides, the ocean's chemistry would have been far more static, and life's chances of emerging might have been much lower. Imagine those ancient shorelines. The land was barren, lifeless rock, but the pools along its edges were alive with possibility. Sunlight glinted off surfaces coated with shimmering films of organic molecules. Tiny chains of RNA-like structures formed and broke apart. Fatty bubbles, precursors to cell membranes, gathered in clusters, holding within them fragments of life's first instructions. Each tidal cycle tested them. Some withstood the ebb and flow, holding together through the waves. Others broke apart, their components washed back into the sea to try again. Over time, the survivors became more complex, better at enduring the moon's steady beat. Even after life began to take hold, the tides continued to shape its path. Currents driven by the moon's pull would have carried nutrients from the deep ocean to the shallows, feeding the first microorganisms. In turn, those microorganisms changed the chemistry of the planet, releasing oxygen into the water and eventually into the atmosphere. The moon was not just a distant observer to this process, it was a driver of the constant mixing that kept the oceans from becoming stagnant. As life became more complex, the tides played a new role. They encouraged movement. In the shallow intertidal zones, organisms had to adapt to being submerged in water during high tide and exposed to air during low tide. Some evolved to cling tightly to rocks, others to burrow into sand, and still others to venture into the shallows only when the water returned. This created a kind of evolutionary training ground, where the ability to survive both wet and dry conditions was a distinct advantage. Eventually, this adaptation would make it possible for life to move from the oceans onto the land, the ocean's pulse also became a kind of clock. Even today, many marine species use the tides to time their reproduction, migration, and feeding. In the earliest ecosystems, this lunar clock would have been even more dominant. Creatures emerged from hiding to feed when the tides brought in nutrients, or released eggs and sperm into the water when the currents could carry them far. This rhythm, set by the moon, became hardwired into the biology of countless species, an invisible link between the heavens and the smallest forms of life in the sea. We sometimes think of life's origins as purely chemical, the result of random interactions and lucky accidents. But the moon's influence shows that it was also mechanical, driven by the push and pull of enormous masses of water over billions of years. This mechanical action increased the chances of life by constantly renewing the environment in which it formed. It was a cosmic stirring spoon, mixing the ingredients again and again until the right recipe finally emerged. Over the ages, as the moon drifted farther from Earth, the tides became gentler. They no longer swept hundreds of meters inland, but their influence remained profound. In shallow seas and estuaries, tidal mixing continued to deliver nutrients and oxygen, sustaining entire ecosystems. The lunar cycle influenced weather patterns, coastal erosion, and even the formation of habitats like tidal flats and salt marshes, which in turn became nurseries for life. It is tempting to wonder what the Earth would be like if the moon had never existed. Without its pull, the tides would be far weaker, driven only by the sun. They would be small ripples instead of great surges, and the dynamic coastal environments we know might never have formed. Without those early tidal pools, life's origins could have been delayed by millions or billions of years, or might never have happened at all. Even now, in our modern age, the moon's role in the ocean's pulse connects us to those ancient beginnings. Fishermen time their work to the tides, sailors know to respect their power, and coastal dwellers feel the changes in the water's reach as surely as they feel the change of the seasons. We stand on beaches and watch the tide roll in, perhaps, without thinking of the moon above. But the connection is still there, as constant as it was 4 billion years ago. The moon does not just light our nights. It moves our seas, it shapes the coastlines, stirs the deep, and keeps the oceans alive with motion. In its pull, we can hear the faint echo of life's first heartbeat, a rhythm set long before there were ears to hear it, a rhythm that continues. Still, as the moon and Earth danced through the darkness together when the Earth was young, it spun with dizzying speed. A single rotation one full day lasted only about 6 hours. The sun would race across the sky, plunging the planet into night before the warmth of morning had even settled in. For the early Earth, there was no lingering afternoon, no long twilight. Light and darkness came and went in a relentless cycle, and the oceans responded with equally relentless tides. This rapid rotation was the legacy of our planet's chaotic birth and the violent impact that formed the moon. The collision with Theia left Earth whirling like a top struck by a hammer. At first, this spin may have seemed permanent, but something in the heavens had already begun to slow at the moon. The moon's gravitational pull doesn't just create tides in the oceans. It also tugs on the solid body of the Earth itself. As the oceans bulge toward and away from the moon, friction between the moving water and the seafloor dissipates energy. That energy has to go somewhere, and much of it comes from Earth's rotation. Bit by bit, the spin slows. It's a quiet, relentless process, measured not in minutes or hours, but in fractions of a second spread across millions of years. Yet, over the course of billions of years, those tiny changes have transformed the length of our days from mere hours to the 24-hour rhythm we know now. In those ancient times, a faster spin meant stronger winds, more turbulent weather, and a greater temperature contrasts between day and night. With the sun rising and setting so quickly, the planet's surface would heat and cool at an unforgiving pace. For early life, struggling to gain a foothold, this was a challenge. Some of the first organisms may have thrived in brief windows of light, only to be plunged into long stretches of darkness that tested their endurance. Plants, when they finally appeared, would have had precious little daylight to perform photosynthesis, their energy gathering limited by the brevity of the day. the moon's gradual slowing of Earth's spin was like a gift of time. Longer days meant longer periods of warmth, more time for the sun's rays to nurture photosynthetic life, and gentler transitions between light and dark. This stability allowed life to grow in complexity, adapting to a predictable rhythm that could be trusted. For millions of years, the extended days and nights also helped moderate the planet's climate, giving winds and ocean currents more time to distribute heat evenly. Even in the earliest oceans, before plants had taken root on land, the lengthening day may have been crucial for the survival of microbial life. Longer daylight hours allowed these microorganisms to store more energy during the day, which they could then use to endure the night. As the moon's steady pull lengthened the day from 6 hours to 8, then 10, then 12, entire ecosystems shifted to take advantage of the extra light. The dance between Earth and Moon shaped the very tempo of life's growth. The slowing spin also altered the tides themselves. When the Earth rotated faster, the tides were more extreme, racing ahead of the moon's motion around the planet. As the days lengthened, the tidal rhythm slowed, becoming less violent but more predictable. For life in the intertidal zones, those regions between high and low tide, this predictability created opportunities. Creatures could begin to anticipate when the water would return and when it would leave, shaping behaviors around this clockwork cycle. In a sense, the moon was not just stretching the length of our days, it was teaching the Earth to breathe more slowly, to settle into a calmer rhythm. And life responded in kind. Over millions of years, longer days may have encouraged the development of circadian rhythms, the internal biological clocks that govern the sleep-wake cycles of nearly all living things today. These rhythms are so deeply embedded in life's design that even now, in the artificial glow of electric lights, our bodies still feel the pull of that ancient cycle. Imagine standing on the shoreline 3 billion years ago, looking up at a moon much larger in the sky, glowing like a silver sun in the night. The tides crash higher and retreat faster than today, and the sun arcs across the heavens with surprising speed. But generation after generation, the day stretches a little longer. The moon drifts a little farther away, its pull on the tides weakening, its influence on the planet's spin continuing. To the early organisms clinging to life in the shallows, these changes are invisible, and yet, they are life-altering. By the time the first plants took root on land, the day had already lengthened enough to give them ample sunlight for growth. By the time animals emerged onto the shore, the 24-hour cycle was nearly in place. These creatures evolved with this rhythm as a constant, never knowing that it had once been so different. The moon had quietly reshaped the tempo of the planet's rotation, ensuring that the world they inhabited was one of balance, with enough time for the heat of day to nurture and the cool of night to rest. The lengthening of Earth's day also had a profound impact on the planet's atmosphere. With longer days, the distribution of heat became more even, which could have reduced the extremes of weather and made the surface more hospitable. The extended daylight encouraged the growth of photosynthetic organisms, which in turn produced more oxygen, eventually leading to the atmosphere we breathe today. The moon's influence on our rotation is woven into the very air that fills our lungs, and still, the process continues. Even now, the moon is slowly pushing itself away from us about 4 centimeters farther every year, and in doing so, it continues to lengthen our days. Millions of years from now, a day on Earth will be slightly longer than it is now. The sun will rise and set a little more slowly, and the rhythm of life will subtly adjust once again. This change is so gradual that no single species will ever notice it, but over the sweep of geological time, it is yet another chapter in the moon's long story of shaping our world. In the grand scale of cosmic history, the moon's gift of longer days is more than just a quirk of orbital mechanics. It is a life-giving force, one that has guided the evolution of the planet's climate, ecosystems, and even the very timing of life's processes. It has transformed the Earth from a rapidly spinning, chaotic sphere into a world where life has the time and space to grow, adapt, and flourish under the steady turning of the sun and the moon's watchful gaze. Long before the first footsteps marked the land, life was bound to the water. The oceans cradled the earliest cells, protected them from the harsh radiation of the young sun, and provided a steady medium for nutrients to flow. For hundreds of millions of years, life remained here, in the embrace of the sea, venturing no farther than the shallows. But the moon, in its silent orbit above, was already at work on a plan that would change everything, a plan to build a bridge from the sea to the shore. This bridge was not made of stone or wood. It was made of water, pulled and released in endless cycles. It was the tidal highway. In the early world, when the moon hung far closer to Earth, its gravitational pull on the oceans was immense. Tides were not the gentle swells we see today. They were vast, sweeping movements of water that surged inland, flooding low-lying areas, and then retreating to expose them again. These shifting borders between land and sea were dynamic zones of opportunity. The moon was, in effect, creating temporary worlds, twice-a-day worlds that were alternately ocean and land, where conditions could change from submerged to dry in a matter of hours. Life in these zones faced challenges unlike any in the open sea. When the tide was in, organisms had to withstand the currents and competition of the water. When it was out, they had to survive in air, with the risk of drying out or being exposed to predators. But these challenges were also opportunities. The tidal pools that formed in rocky crevices or sandy depressions became isolated microhabitats. In them, water trapped by the receding tide warmed under the sun, concentrating nutrients and creating safe pockets for small organisms to feed and reproduce. Here, competition was less intense than in the open ocean, and the rewards were great for those who could endure the changing conditions. The moon's tidal cycles created a natural training ground for the first creatures to test life on land. Organisms that could tolerate brief exposure to air, perhaps by trapping water inside their bodies or developing stronger outer coverings, had an advantage. Over countless generations, these traits became more refined. The tidal zones selected for resilience, flexibility, and the ability to move between environments. Step by step, life began to explore beyond the water's edge. Fossils tell the story of this gradual migration. The earliest tetrapods, the ancestors of all land vertebrates, appeared in shallow, tidal environments. Their fins began to evolve into sturdy limbs, capable of pushing through mud or lifting them in the shallows when the water receded. It was not a sudden leap from sea to land, but a slow, rhythmic journey, paced by the tides. When the moon pulled the sea back, creatures ventured into the exposed world. When it returned, they slipped back into the safety of the water. Over millions of years, this cycle gave rise to the first true land dwellers. Even plants may have followed this same path. Algae and other early plant-like organisms thrived in tidal zones, where periodic exposure to air encouraged adaptations for surviving dryness. These adaptations eventually paved the way for the first mosses and ferns to colonize the land, creating new habitats for other organisms to follow. The tidal highway did not just transport animals, it carried entire ecosystems. What made the moon's contribution unique was its reliability. The sun also affects the tides, but solar tides are weaker and less predictable on their own. The moon provided a consistent rhythm, a dependable rise and fall that life could anticipate. This predictability allowed organisms to evolve in harmony with the lunar cycle. Many modern species still carry this connection in their biology. Crabs and fish that spawn at specific phases of the moon, turtles that come ashore to lay eggs during high tides, and countless coastal creatures that feed according to the lunar timetable. These ancient instincts are echoes of the first steps taken along the tidal highway. The highway itself has changed over time. As the moon drifted farther from Earth, the tides grew gentler. The once massive surges gave way to the smaller but still significant movements we see today. Yet even in this softer form, the tidal highway remains active. Every day, water floods the coasts and retreats again, exposing and covering stretches of shore. Migrating birds follow these cycles to feed on exposed mudflats. Fish use them to enter and leave estuaries, and humans harvest shellfish by the moon's schedule. The connection between life and the tides has never been broken. Without the moon's pull, the story might have been very different. Without strong tides, the boundary between land and sea would have been more static, offering fewer opportunities for life to experiment with new environments. The slow march onto land might have been delayed by tens or even hundreds of millions of years. The lush forests, diverse insect life, and eventually mammals that evolved on land might never have had the time to appear before Earth's climate shifted again. The moon's role was not just to stabilize our planet or light our nights. It was to act as a cosmic conductor, orchestrating the movement of water in a way that encouraged life to take the greatest leap in its history. The tidal highway also served another function. It linked distant parts of the planet. Tides do not simply rise and fall in place. They move water across great distances, carrying nutrients, sediments, and even tiny organisms from one region to another. In this way, the moon helped connect ecosystems, spreading life's building blocks across coastlines and accelerating its diversification. Genetic material could travel from one tidal pool to another, increasing the chances for adaptation and innovation. Even today, when we stand at the edge of the ocean and watch the waves roll in, we are watching the same highway in motion. The sand beneath our feet is shaped by it. The shells scattered along the shore are products of it, and the patterns of life in the intertidal zone are dictated by it. Every ripple and retreat is part of a chain of events stretching back billions of years, to the time when the moon first began pulling the oceans into motion. For the creatures that took those early steps onto land, the tidal highway was both a challenge and an invitation. It tested their ability to adapt, to survive into worlds. And for those that succeeded, the reward was a new frontier, a place where sunlight was constant, where food was different, and where predators from the sea could not follow. From those pioneers came the vast array of land-based life we know today. Towering trees, buzzing insects, reptiles basking in the sun, birds filling the air, and mammals roaming the plains. All of it traces back to that shifting shoreline, shaped by the pull of the moon. From the moment the moon emerged from the molten aftermath of Earth's great collision, it began serving as more than just a silent companion. It became a protector, a shield against the chaos of the cosmos. The Earth, for all its beauty, is a delicate system balanced between extremes. A shift too far toward one side could bring ice and silence. A push toward the other could bring heat and ruin. Without the moon's steadying influence, our planet's path through space might have been far less peaceful. The Earth spins on its axis like a gyroscope, tilted at just the right angle to give us our seasons. But this tilt is not locked in stone. It is influenced by the gravitational pull of other worlds: Jupiter, Saturn, Mars, each tugging on us as we move around the sun. Over long periods of time, these forces can cause the axis to wobble, shifting our tilt and, in turn, our climate. With the moon standing guard, these wobbles are small, mere degrees over tens of thousands of years. Without it, the changes could have been catastrophic. Imagine a world where the tilt swings from near 0 degrees to over 60 degrees. A near zero tilt would erase seasons altogether. The poles would be in permanent twilight, and the equator would swelter under relentless heat. Ice caps might grow so vast that they lock away most of the planet's water, turning the Earth into a frozen desert. At the other extreme, a 60-degree tilt would bring seasons of unimaginable intensity. A single summer might flood the poles with unending daylight, melting all ice and raising sea levels by hundreds of meters. A single winter might plunge them into 2 years of darkness, freezing oceans solid. Life would have to endure climate whiplash on a scale that could wipe out entire species before they had a chance to adapt. The moon's presence dampens these extremes. Its gravitational grip on the Earth's equatorial bulge acts like a stabilizing hand on a spinning top, resisting the tugs of other planets. In doing so, it ensures that the tilt remains within a narrow, livable range. This stability has allowed life to evolve over billions of years without being erased by sudden, planet-wide climate disasters caused by runaway axial shifts. Toc. What might have been? We need only look at Mars. Mars has no large moon to steady it, and over millions of years, its tilt has swung wildly from 10 degrees to more than 60 degrees. These changes have transformed its climate again and again, thawing ice and then freezing it, creating and destroying rivers and lakes in cycles that may have made it impossible for life to gain a permanent foothold. Earth, by contrast, has enjoyed long stretches of relatively gentle change, giving evolution the time it needs to craft complexity. The moon has been the difference between chaos and calm. The shield it provides is not only against the forces of other planets, but also against the random events that ripple through our solar system. Gravitational interactions between planets can sometimes cause subtle shifts in orbital paths, tiny changes that, over millions of years, could destabilize a planet's rotation or alter its climate beyond recognition. The moon's mass and proximity give Earth an added layer of stability in the face of these cosmic nudges. It locks our rotation into a kind of gravitational partnership that resists the pull of far-off giants like Jupiter and Saturn. Even the rhythm of our ice ages bears the moon's imprint. The cycles that bring ice sheets creeping across the continents and then retreating again are partly driven by changes in Earth's tilt and orbit. Without the moon, these cycles might have been far more extreme, perhaps plunging the planet into snowball Earth states that could last tens of millions of years, or into greenhouse conditions that could boil away shallow seas. Instead, the cycles remain within a range that life can survive harsh, yes, but not fatal to the biosphere as a whole. Some scientists have even suggested that the moon's stabilizing effect may have been crucial to the rise of human civilization. Agriculture, which depends on predictable seasonal changes, might never have taken root in a world where the tilt swung wildly from generation to generation. Without the moon's shield, humanity's story might have been one of constant migration, chasing habitable climates that shifted unpredictably across the globe. The great cities and cultures we know today could have been impossible in such a restless world. The moon's role as a shield extends beyond the gravitational. While it does not physically block incoming asteroids or comets, its formation may have reduced the chaos in the early solar system in another way. The massive impact that created the moon likely swept away or altered the orbits of many smaller bodies that might otherwise have bombarded Earth for eons. The presence of a large nearby satellite may also subtly influence the paths of incoming objects, though this effect is minor compared to its gravitational stabilization. Still, the moon's very existence is a reminder of the violent events that shaped our world and how stability can emerge from destruction. On a human timescale, the moon's shield is invisible. Our seasons feel steady. Our climate, though changing now through our own actions, has been consistent enough for thousands of years to sustain the rise of civilizations. But on the scale of geological time, the moon's protection is monumental. It has kept the Earth's dance through space graceful and predictable, allowing life to take root and flourish without the constant threat of planetary upheaval. And yet, this shield is not permanent. The moon is slowly drifting away from Earth, its orbit widening with each passing year. As it moves farther out, its stabilizing influence will weaken. Millions of years from now, the Earth's tilt may begin to wobble more dramatically, and the stability we take for granted may fade. But for the entire history of life so far, the moon has been close enough to hold the planet steady, its invisible tether keeping chaos at bay. When we look at the moon hanging in the night sky, serene and unchanging, it's easy to forget the work it is doing, work that has been ongoing for billions of years. It is not simply a light in the darkness. It is a guardian, a cosmic anchor holding our world in a delicate balance. Without it, the Earth would be a place of extremes, a planet where stability was a rare and fleeting gift, and where the story of life might have been far shorter and far less rich than the one we are living now. Long before electricity painted the night with its artificial glow, the only light that touched the darkness came from the stars and the moon. The moon, in particular, was the great lantern of the night sky, not as blinding as the sun, but steady enough to shape the rhythms of life itself. It was a light that could not be switched off, a luminous companion that waxed and waned in a slow, predictable dance. For countless generations of living things, this glow was more than beauty. It was guidance, it was safety, it was a clock written in silver across the heavens. In the ancient seas, long before the first forests breathed, moonlight reached into the shallow waters, faint but certain. Many marine creatures evolved to sense it and respond to its cycle. Corals, for example, time their mass spawning events to the phases of the moon. Once a year, when the moon's light strikes the water at just the right angle, millions of coral colonies release their eggs and sperm into the sea in a synchronized spectacle. This timing ensures that the chances of fertilization are maximized and that the young will drift into a world where predators are momentarily overwhelmed by abundance. Without the moon's dependable cycle, such coordination would be far more difficult, and the intricate reef ecosystems we know today might never have flourished. On land, too, the moon's light became a silent metronome for life. Many species of insects, reptiles, and birds use it as a cue for migration or mating. Sea turtles, for instance, emerge from the sand under the cover of night, guided by the brightness of the moon reflecting off the ocean's surface. In the deep past, before human light pollution disrupted these patterns, this lunar glow was the safest signal. They knew, the assurance that the path ahead led to water, to survival. Predators have also learned to read the moon. Nocturnal hunters such as owls, wolves, and big cats adjust their behavior based on the moon's brightness. On nights of a full moon, when prey animals are more easily spotted, hunters may move more cautiously or wait for darker nights to strike. Meanwhile, prey creatures themselves have adapted in turn, using the changing levels of lunar light as a cue for when to forage and when to hide. This delicate interplay, predator and prey both shaped by the glow of a distant rock in the sky, has been refined over millions of years. For early humans, the moon's light was more than a biological signal. It was a source of security. In a dangerous world, in the deep dark of a moonless night, the forest and plains were filled with unseen threats. But on nights when the moon rose full and bright, the world opened up. People could travel farther, hunt longer, and gather beneath its glow to share food, stories, and songs. Long before the invention of firelight, the moon was humanity's first lamp, a constant in the night that encouraged exploration beyond the boundaries of the day. It was also a calendar in the sky. The moon's cycle, predictable to the day, gave early societies a way to measure time. Farmers could track planting and harvesting seasons. Sailors could navigate tides, and communities could schedule gatherings and rituals. Many of the world's oldest calendars are lunar or lunisolar, each month beginning with the moon's rebirth as a thin crescent. Even now, cultural and religious festivals around the globe are tied to the moon's phases. Ramadan, the mid-autumn festival, Easter, Diwali, each one a living thread connecting us to those who first looked up and saw in that silver arc a measure of life's passing. But the moon's role as a nightlight is not only about visibility. Light affects biology in subtle ways, influencing hormones, sleep cycles, and mood. The presence of the moon at night may have shaped the circadian rhythms of early animals, and perhaps even humans, by providing an intermediate light level between the extremes of day and absolute darkness. In evolutionary terms, this may have given rise to crepuscular behavior, the tendency of certain species to be most active at dawn and dusk, when light levels are low but not absent. The moon extended these hours into the night, opening new opportunities for feeding and movement without the risk of blazing daylight. In some parts of the world, indigenous peoples developed intricate navigation techniques using the moon. Polynesian voyagers, for example, used its position along with stars, waves, and wind patterns to travel thousands of miles across open ocean. The moon became part of a complex system of celestial mapping, a glowing waypoint on the grand highways of the sea. Without its predictable path, such feats of navigation might have been impossible in the pre-compass age. The moon's light also shaped myth and meaning. Across cultures, its phases became metaphors for life cycles: birth, growth, decay, renewal. Poets saw it as a mirror of human emotion, changing yet constant. Priests and shamans interpreted its waxing and waning as signs from the divine, guiding decisions from planting crops to waging wars. This symbolic weight may have encouraged early humans to watch the moon more closely, reinforcing its role as a regulator of daily life. Even in ecosystems untouched by human eyes, the moon's glow continues to govern the lives of creatures great and small. Some fish time their vertical migrations rising to the surface at night to feed with the moon's brightness, avoiding predators when the night is too well lit. Certain insects synchronize their mating flights to moonlight, ensuring they find partners over vast distances. In the polar regions, where the sun may disappear for months, the moon becomes an even more critical source of light, guiding animals. Through the long, cold dark, there is a subtle romance in the way moonlight works, not in the human sense of candlelit dinners and whispered promises, but in the way it binds the living world together through shared reliance. It is a common denominator across species and continents, a light that needs no fuel, that cannot be hoarded or owned. Every being under the sky receives it equally, from the smallest plankton drifting in the sea to the eagle scanning the tundra. And yet, the moon's nightlight is not a constant blaze. It is a rhythm, a pulse brightening toward fullness, then dimming toward newness, and repeating endlessly. This slow heartbeat of light and dark has taught life to move in cycles. It has given rise to migrations that span thousands of miles, breeding events that occur within hours across entire species, and cultural rituals that have endured for millennia. To imagine a world without the moon's light is to imagine a world where much of this rhythm disappears, replaced by randomness and uncertainty. The moon's glow is a paradox faint enough that you can still see the stars beyond it, yet strong enough to leave a shadow in the dust. In that balance, it has quietly shaped the evolution of life. Not through force, but through presence. It has been the whispering guide in the darkness, the silent witness to every night since life first dared to leave the safety of the sea and walk under the open sky, long before humanity learned to shape metal into clockwork or to send signals through wires. There was only the sky. The heavens were the great calendar and compass, and among all the lights above, none was as trustworthy as the moon. The sun marked the days, but the moon carried the subtler rhythm, the weeks, the months, the cycles of growth and rest. It was not just a light in the darkness, it was a keeper of time, writing its schedule across the heavens in a language so consistent that even the earliest humans could learn to read it. A single lunar cycle from new moon to full moon, and back again, takes roughly 29.5 days. To our distant ancestors, this was an elegant gift, a natural unit of time, long enough to plan journeys or rituals, short enough to be observed without the long wait of a full year. In many ancient cultures, the moon's phases became the primary measure of time, far older than the 12-month solar calendars most of the world uses today. A month was literally a moonth, a slice of the year carved not by human invention, but by the turning of a celestial body that never failed to keep its pace. This lunar measurement was more than practical. It carried with it a sense of connection to the cycles of the earth itself. Farmers looked to the moon to choose when to plant and when to harvest, believing that the rising sap in plants followed the pull of the moon's gravity much as the tides did. Some of these beliefs have echoes in modern agricultural traditions, where lunar planting calendars still suggest the best times for sowing seeds or pruning trees. Whether or not the science matched the observation, the faith in the moon's timing tied human labor to the cosmos in an unbroken line, from the first sowers of seed to the gardeners of today. Seafarers, too, relied on the moon's regularity. The tides it governed became both a challenge and a guide. Navigators of the ancient world, particularly those of the Pacific Islands, could read the moon's position and use it to estimate their location on vast, open waters. For them, the moon was not just a light above, it was a point on a map, a partner in voyages that spanned hundreds or even thousands of miles without the help of a single modern instrument. This ability turned the moon into a symbol of safe passage, and in many maritime cultures, prayers and offerings were made to it before setting sail. The cultural imprint of the moon deepened as civilizations grew. In Mesopotamia, the Sumerians and Babylonians wove lunar cycles into their systems of law, commerce, and religion. Their months began with the first visible crescent, and festivals were arranged around full moons, when night travel was safer and gatherings easier. In China, the lunar calendar formed the backbone of societal rhythm, dictating the timing of New Year celebrations, harvest festivals, and ancestral rites. The Mid-Autumn Festival, with its mooncakes and lanterns, is a direct descendant of this ancient lunar awareness, celebrating the harvest under the year's brightest moon. In the Islamic world, the moon remains central even today. The Islamic calendar is purely lunar, with each month beginning when the new crescent is sighted. This determines the dates of Ramadan, Eid al-Fitr, and Eid al-Adha, events that unite millions around the world in shared observance, their timing dictated not by mechanical calendars, but by a body orbiting nearly 384,000 kilometers away. In Judaism too, the lunar cycle plays a role, with many holidays tied to phases of the moon, though balanced with solar adjustments to keep the seasons aligned. Even in the Western world, where the Gregorian calendar is dominant, echoes of lunar timekeeping remain. The names of the months are relics of older systems, and certain religious observances, most famously Easter, are still set according to a blend of solar and lunar timing. The date of Easter is calculated as the first Sunday after the full moon that follows the spring equinox, a formula that is a quiet reminder of the moon's lasting influence over human life. Beyond marking time, the moon shaped the myths and stories through which cultures understood their place in the world. To the ancient Greeks, the moon was Selene, a goddess riding her silver chariot across the night sky. The Romans saw her as Luna, divine and eternal. In many Native American traditions, the full moons of each month were given names that reflected the seasonal changes on Earth: the wolf moon of January, the strawberry moon of June, the harvest moon of September. These names were not just poetic. They were practical markers for when to hunt, gather, or prepare for winter. In other cultures, the moon's phases became metaphors for the human condition. Waxing was growth and youth. The full moon was strength and maturity. Waning was decline and death, followed inevitably by rebirth. The moon's ability to vanish entirely and then return was seen as a promise that endings were not final, that light would come again. This belief gave hope to people whose lives were often ruled by forces beyond their control. Art, too, absorbed the moon's influence. It appears in cave paintings, carved into bone and stone, drawn on pottery, written into epics and songs. In every era, artists have looked to its shifting face for inspiration. Sometimes it was a symbol of romance, other times of solitude, mystery, or madness. Its phases offered a visual poetry that could be read by anyone, anywhere on Earth. The moon even affected language itself. Words like month and Monday are born from it. In some languages, the word for moon and the word for month are still the same. In others, the moon is tied linguistically to concepts of change, reflection, or cycles. This subtle embedding of lunar influence into our daily speech is a reminder of how deeply it has been woven into human thought. In the realm of science, the moon's predictable orbit provided a foundation for astronomy. Ancient astronomers used its motion to refine their understanding of celestial mechanics, noting how its rising and setting times shifted by roughly 50 minutes each day. These observations led to more precise calendars and eventually to the understanding of eclipses, which in turn fueled the growth of mathematics and navigation. Without the moon's reliable path, much of humanity's early grasp of the cosmos might have taken far longer to develop. And then there is the moon's role in uniting humanity under a single shared experience. Wherever you are on Earth, you see the same moon, though from slightly different angles. This universality means that people separated by vast distances have always shared its phases. In ancient times, this may have been one of the few ways that humans in different lands could experience something simultaneously, binding them in a quiet, cosmic fellowship. Even now, in the age of satellites and instant communication, the moon still has this rare power to connect us. The moon's role in timekeeping and culture is not a relic of the past. It continues to influence our schedules, our stories, and our sense of belonging. In an age when atomic clocks can measure the passage of time to billionths of a second, we still look up and measure our lives in the slow, steady turning of a glowing sphere that has watched over Earth since long before we arrived. And so, when we look up at the moon tonight, whether it is a slender crescent clinging to the horizon or a bold, silver disk sailing high above, we are not just looking at a beautiful object in the sky. We are looking at the silent architect of our world. Without it, Earth's tilt would wander, our seasons would become erratic, and the tides that nurtured the first life might never have existed. The moon has been our time cue, our stabilizer, our shield, and our muse. It has told us when to plant and when to harvest, when to set sail and when to stay ashore. It has shaped our myths, our languages, our calendars, and our dreams. It has been the steady pulse against which all of life's rhythms have been measured, a presence so constant that we forget how much it does until we stop and think. The oceans breathe because of it. The nights are softer because of it. Humanity's oldest stories shimmer with its light. The moon is not just a companion in the dark. It is part of the reason we are here at all. So, the next time its pale glow spills across your window, remember that it is not a distant stranger. It is an ancient partner, moving endlessly around us, holding our planet steady, and quietly making life possible.